Good morning, students. Today class will be based on the graphs of the chapter motion. So I hope you will get interesting to know more about the graphs from the today's video session. So without making late, let's start. In order to understand the motion, it is very important to know the graph. So if you know the graph properly, then you can represent the motion in very simple way, which will speak everything that is there or everything that has been happening to the body which is in motion or which is in rest. So in order to describe the motion of a body or in order to describe the speed or position, velocity, acceleration of a body, it is very much important for us to know graph. So if we could represent the motion of a body in graph, then we can convey many things that are not easily conveyable if we say all those things verbally. Let us understand it by taking an example. Suppose your friend is going to some place and after going there he rests there for some minute and then he returns with some uniform motion, and after covering certain distance it increased its speed and the acceleration here is constant, and later on he made his acceleration uniform, and it will be very difficult for one to understand what has happened while the body is in motion. Right, if you are going to convey the thing, all the things that has happened to you while you are in motion to someone, then it will be very difficult for you to say all those things, and there is a chance that while saying all the things that have happened to you while in motion, you may make some wrong, and it will be difficult for the one who have listened, who is listening to you regarding the motion to understand. It will be very difficult for the listener to understand what type of motion was there. So if you could plot a graph and you could show the thing that happened to you while you were in motion in a graph, then without saying anything you can convey everything that we can say. So graph is that much important in chapter motion. So now let us know what are the types of graph that we will be coming across if we are dealing with the chapter motion. So basically we will be coming across three types of graph, that will be distance time graph, speed time graph and acceleration time graph. So there is a little difference between distance time graph and displacement time graph. So we shall be covering the displacement time graph in the same time when we will be covering distance time graph, and there is also a little difference between speed time graph and velocity time graph. We shall be covering this also at same time, and the third will be acceleration time graph. See, most important here is these two types of graph for exam point of view: distance time graph and speed time graph. Acceleration time graph is not that much important, so we shall be discussing what the things are there in this and how to represent the motion using all these three types of graph. First, we shall be discussing the distance time graph and the displacement time graph, and the difference between the distance time graph and displacement time graph I have already said you in previous class. And while dealing with distance time graph, I shall be pronouncing or I shall be saying distance time graph most of the times, right? So while dealing with distance time graph, we may come across two types of graph. One may be either straight line or it may be curve. Right. So if it is straight line like this in this graph, you can see the line is straight. Here in second graph the line is curved, the third curve upward, and in third the line is curved down. So what is the difference between these two, between curving upward and curving downward? Let us see that, then we shall be seeing this one. See, here you can see, here what will be happening, here as the time passes the speed goes and increases, right? Because at first it will be covering in 1 second. If we divide the time axis as this, like this, let's say this is 1 second, second, third second, fourth second, fifth second. First we will observe that in 1 second it has to travel, it will be traveling this distance, and in second it will be traveling this distance, in third second it will be traveling this distance, and fourth second it will be little more. So you can say that here if the curve is If the graph is curved upward, then the speed is increasing in case of a distance time graph. Similarly, if you observe the same thing in case of a distance time graph, if the graph is curved downward, see here initially the speed is higher, which goes on decreasing, and by this time you can see that the time may goes on increasing, but the distance do not increase, distance will be remain until same. So it just means that the speed goes on decreasing in this case. Right. So now here let us see what has happened. Here the speed is constant, which can be known from the straight line of the graph. Right. If the graph is straight line in case of a distance time graph, then the speed is constant, or we can say that the amount of distance covered by the time is proportional. Amount of distance covered by the time is always constant. If we say in 1 second this distance, 2 seconds this distance, 3 seconds this distance, 4 seconds this distance, you can find out the proportionality. Same amount of distance you will be covering in same time. Or you can say that the speed here will be uniform speed. Uniform speed. Right. So in case of a distance time graph, we need to understand what is slope, and if we find out slope of this graph, what we shall be getting by finding out slope. What we shall be getting is find out area. That we shall be discussing after covering all these three types of graph, and we shall be also knowing what is slope actually and how to find that we shall be discussing. Now let us understand the velocity time graph. See, we discussed three cases in which one of the cases is in which the distance covered by the body will be uniform, means the distance covered by it will be same in same interval of time. And in second case we discussed if speed goes on increasing, or the distance covered by the body per unit time goes on increasing. In the third case, if the distance covered by the body goes on decreasing, what shall be the graph, or how shall be the graph. And one thing I forgot to say, if the body is at rest, how shall be the distance time graph? See, if now we shall be doing the distance time of the body which is at rest. Let us say the body has travelled some distance of 4 meter, and after travelling 4 meter, the body is in rest. Now when we plot the graph, let's say this is our 4 meter. So after 4 meter, the graph will be a straight line, which is parallel to the time axis. Means the time will be passing, but the distance covered by it will be as the time passes will be not. The time will be passing, but the distance will remain the same, which is 4 meter as we have assumed. So same thing also happens if the body has not covered any distance. The body has not covered any distance, and from initially it is at rest. So the time will be passing, and the graph will be coinciding the time axis, because here the body has travelled 0 distance, and after travelling 0 distance it is at rest. Or you can just say that the body has not yet started any motion, it is at rest. If the same thing happens if the body has covered 5 meter, and after 5 meter the body is in rest, and after 5 meter travelling of the body of 5 meter, we are plotting the graph. We can say that the body has covered, let's say this is our 5. So after covering 5 meter, the body is at rest. So after 5 seconds, or after 5 meter covering 5 meter, the body will be like this. The graph will be like this, which will be parallel to the time axis. Right. So this will be the graph for a body which is at rest. Graph of distance time graph for a body which is at rest. Now let us discuss velocity time. See, earlier we have read if the distance time graph is a straight line, and it means that the speed is uniform. If the distance time graph is curved upward, it means the speed is going on increasing, and if the distance time graph is curved downward, the speed is going on decreasing. So if we plot the same thing in a velocity time graph, how shall be the graph? By comparing the things, you can get a better understanding. Right. See here we distance time graph, the body is covering equal distance in equal interval of time, or you can say that the body is in uniform speed. So if it is in uniform speed, it just means that its speed or velocity remains constant, right? So while saying you regarding graph, I shall be using speed or velocity. You don't get confused. Both means same. Consider it for a while. Both means same, right? So here, if the in distance time graph, if the graph is a straight line, it just means that the speed is uniform. If speed is uniform or speed is same throughout, and we plot the graph of this motion in a velocity time graph or speed time graph, it will be a straight line, right? Because speed is uniform, or you can say speed is constant throughout. So if speed is, let's say here x, so the speed will be x throughout the time or throughout the motion, right? Similarly, what happened here? Here we got that the distance is going on increasing gradually, right? Or distance covered by the body per unit second goes on increasing. So here, if we plot the graph of this distance time graph in velocity time graph, it will be like this, right? See, you can see that the speed goes on increasing. If we say that distance goes on increasing per unit second gradually, it just means that its speed is increasing. So if its speed is increasing, like this we can represent it. Similarly, if we represent this graph in velocity time graph, here where the speed is decreasing, similar thing we have to do. It will be like this, right? It will be downward, it will be going upward, and it will be a straight line. Now here, if one thing may come to your mind, if the body is at rest, how shall be the graph? Let's say here, this is distance time graph. The body is at rest after traveling this distance. So how shall be the graph in velocity time graph? If the body is at rest, means the distance covered by it is also 0. Distance or speed of the body is 0. So speed will be coinciding with the time graph.